All right, so let's do an example of solving the simplest form of inequality, that is a linear inequality. So linear is in reference to the idea that these are related to lines somehow. And in fact, if you look at this, if we were to set y equal to 7x minus 11, that would give us a line. Likewise, if we set y equal to 2 times x minus 3, this would also give us the graph of a line. Basically speaking, when we talk about linear expressions, we're talking about some sort of number times a variable just by itself, plus or minus another variable. And in fact, if we were to distribute the right-hand side, we should notice that this is in fact very similar to the equation of a line. Now, solving linear inequalities is essentially the same as solving linear equations. What we're going to do is we're going to do the usual adding, subtracting, dividing, isolating variables, the steps that you're used to from your previous algebra courses, but we now have the caveat that when we multiply or divide by negative numbers, we need to be a little careful. All right, so if we look at this expression right here, we can go ahead and ask, okay, let's move all the variables to the left side and let's move all the values without variables to the right side, okay? To do that correctly, what we need to do is we need to do the same thing to both sides of the inequality. So in this case, what we're going to do is we're going to subtract 2x from both sides. So these two x's will cancel and it's effectively moved over to this side. And we're going to add 11 to both sides. So that effectively moves the 11 over to the other side. Now, if we look at this, 7x minus 2x leaves us with 5x. Negative 11 plus 11 is 0, so we're going to just not write that down. Adding 0 does nothing. And then this is going to be less than or equal to, well, 2x minus 2x again is 0, so nothing happens. And then negative 6 plus 11 is going to give us 5. All right? Now, if we look at this, we're going to divide both sides by 5. We want to get that x by itself. And if we look at this, we'll notice that, well, 5x divided by 5 will just give us x, and 5 divided by 5 will just give us 1. And so the solutions will be all x's that are less than 1. All right, so this includes 0.5 and 0.25, as well as 0 and negative 1 and negative 257, for example. And so this is all the solutions to this inequality. Let's look at doing this a slightly different way. I'm going to take it up at this step right here and show you a slightly different method that'll give you the same answer. Now instead, what we're going to do is we're going to move all the variables to the right and all the non-variable expressions to the left. So to do that, what we're going to do is we're going to subtract 7x from this side, and we're going to add 6 to both sides. If we look at this, 7x minus 7x is 0, so it just disappears, and negative 11 plus 6 will give us negative 5. That's going to be less than 2x minus 7x, which will give us negative 5x. And then negative 6 plus 6, that'll just give us 0. So if you notice, we're in a somewhat similar inequality as before, but instead of having 5s, we have negative 5s, and instead of x being on the left, it's now on the right. Now the natural step to do is to divide both sides by negative 5. And if we notice, this number is negative. So if we have a negative divisor, what that means is we flip the inequality. And if we do that, negative 5 divided by negative 5 is 1. We need to flip the inequality because this is negative, so we're going to have 1. And that's going to be greater than, well, when we divide out the negative 5, we're just left with x. And if you'll notice, this is the same inequality as before. That is, if 1 is greater than x, then, pardon me, x is less than 1. And so this method will work for any linear inequality that you hold, where both the expressions on both sides just simply look like lines.